6.2a is inverse functions. We're going to find the inverse of a function, and the inverse is kind of like the opposite. I know that's not technically correct, but if I said +2, you're going to say -2. And if I said ×3, you're going to say divide by 3. So we're trying to find the operation that cancels out another operation, or a list of operations. So write this down on the back of the paper. These are important steps. This is what we're going to do over and over again. Step 1, change the f of x into a y. Step 2, switch x and y. Step 3, isolate y, or solve for y, get it by itself. Step 4, change y equals x back to the f of x notation. So notice it's going to be a f prime. So f apostrophe, that's how we're going to show it's the inverse. So f prime of x, or f inverse of x. Let's look at number 1. Step 1 just says change this to y. So let's just mark on top of that. Step 2 says switch x and y. So all I'm going to do is interchange x and y. So I have x equals 1/3 y plus 2/3. Step 3 says isolate y. And so we're trying to get y by itself. I do have a math trick here. Most of us don't really like dealing with fractions. So I'm going to do a little trick to get rid of the fractions. So what I'm going to do is, in order to cancel out the 1/3, I'm going to multiply both sides by 3. But we're going to multiply everything by 3. And that 3 is going to cancel here and here, leaving me with 3x equals 1y, or we'll just say y, plus 2. So we're still inside step 3. Step 3 says isolate the variable, isolate y. And in order to get y by itself, we'll just subtract 2. That'll give me y by itself. I'm going to switch sides here. But y equals 3x minus 2. That's basically done. All we have to do is the last step. Step 4 says change this y back into your function notation, but put that little prime there. That prime is what says it's an inverse. So f inverse of x equals 3x minus 2. Let's look at number 3. It's pretty much the same deal. We're going to change that to a y, and then interchange x and y. Let's see if we can write small here. X equals -1/6 y minus 2/3. Step 3 is isolate y, but we've got those pesky fractions. So what I'm going to do here, I'm not going to multiply by 3, I'm going to multiply by 6. Essentially, you want to multiply by the least common multiple, and that'll knock out both of your fractions. So we're going to multiply everything by 6, both sides by 6, every term by 6, and it's going to cancel here. And it's kind of going to cancel here, but the reason it cancels is because 3 goes into 6 twice. So technically, 3 goes into 6 twice. You're going to have a 2 there to deal with. But we look at what we have here, and that is 6x equals, the 6 canceled, so we have negative y, or -1y, minus, we have this 2 times this 2 is going to be 4. Pretty good. Need to isolate the y. So we're going to add this 4 over. And I see the minus y by itself equal to 6x plus 4. And that's not finished because I don't have y by itself. I have minus y. So we're going to use kind of a similar trick to what we did with the fractions. We're going to multiply everything by -1. Multiply all the things by -1, but that's just going to change all the signs. Multiply by -1, multiply by -1, multiply by -1, and I'm going to see y equals -6x minus 4. Last step, change that back into your function notation. F prime of x, or f inverse, equals -6x minus 4. Let's move over and do problem number 4 this time, because number 5 is pretty much the same thing. You've got those fractions to deal with. Let's look at number 4 because it just looks different. Change this to y. switch x and y. Now I need to isolate. And in this case, I can still get rid of the 5. The 5 is a division, the 5 is a fraction. I can still do kind of the same thing to get rid of the 5. It works a little bit different because there's only one fraction. I only have to do it one time. And it's going to cancel out. So it's tempting to try to distribute that 5, but we don't distribute the 5 because it canceled out. I would see 5x equals 3y plus 9. And I'm isolating, so I'm going to subtract this 9 over. Switch it around. 3y's by itself. I've got 3y equals 5x minus 9. And then I'm going to divide by this 3. Y equals 5/3 x minus 9 over 3 is 3. So I always reduce when I can. And that's the hard part. Last step, put it back in function notation. F prime of x equals 5/3 x minus 3. All right, I just caught a mistake. Kind of minor, I guess, but this wasn't an F, this was a G. So technically I should not have said F inverse, I should have said G inverse. So go back and look at the others. Yeah, number 3, I did the same thing, right? It was a G, so this should have been a G. About number 1. Number 1 is fine. Number 1 was an F, so I said F inverse. Numbers 3 and 4 were G, so I should have said G inverse. Okay, so more of the same until we get down to the bottom here, and these are review problems. So number 9 is a subtraction, number 10 is a multiplication, 11 and 12 are compositions. And so look at number 11 because it's kind of tricky. When you see G of f of a, that's a composition, and I like to think of it as G of f of a. Looks like that. And what that means is we're going to take a and stick it into that f equation. But if you do that, we already know exactly what that looks like. A inside the f of equation is just 3a plus 1. So it's kind of a silly question here because we already know f of a is 3a plus 1. But now what we have to do is we have to take that and put it into the g equation. So that means put it in right here. The g equation says 4 times something minus 4. And what we're doing is sticking in that 3a plus 1. So this is going to involve a little distributive property. 4 times 3a plus 1. That's 12a plus 4. And don't forget to subtract 4. Combine your like terms. Those two knock each other out. You're left with 12a. And that's your answer. G of f of a equals 12a.